So we are starting today with a new type of integration problem. This is lecture number 13 on indefinite integration. We are starting with a new type, so I write the type here. The type is integral 1 upon ax square plus bx plus c dx. Where a, b and c are real constants. They are real constants. If you remember, students, in lower standard you have solved the quadratic equations. And how did quadratic equation look like? It looked like this: ax square plus bx plus c equal to 0. So I call this as a quadratic equation because I have got an equal to sign. See here, you have an equal to sign, so you call it as a quadratic equation. Moreover, it is equation because of this equal to sign. Moreover, you have a quadratic expression on left hand side. Why this is quadratic expression? Because the highest power of x is 2. The highest power of x is 2 here, and a is not 0. So this is a quadratic equation. So if I have only the left hand side, what would I call this as? If I don't have the equation, that is, I don't have equal to sign and 0, I have only ax square plus bx plus c, then what should I call this as? This is a quadratic expression. It's a quadratic expression. So here the type that we are using, we are going to integrate, it is 1 upon ax square plus bx plus c, that is 1 upon quadratic. What it is a 1 upon quadratic expression. So in this type we are going to learn, if I have any question, if I have a question where I have to integrate, say something like 1 upon 3x square plus 5x plus 7 dx. If I have to integrate this, how would I integrate? So having learned this type, today when we will have completed the integration of this type, we'll be able to solve all such, we will be able to integrate all such functions. So this is 1 upon quadratic expression. So you can also call this type as 1 upon quadratic dx. You can also call this as 1 upon quadratic dx. So after this type, we will write the method. How do we integrate this? Let us write the method. Let us write the method. The method is step 1. Write the coefficient of x square equal to 1. You can say make the coefficient or write the coefficient, whichever is proper. You can, so even you can say make the coefficient, because it is we are making it. Okay, so if you have some coefficient of x square, which you notice, like a is the coefficient of x square, and you notice that it is not 1, it is, say it is 2, it is -3, it is something other than 1. So what is the first step? The first step is you will make this as 1. Then step 2 is find the proper last term find the proper last term for the quadratic expression, using the formula, I write the formula here. Last term equals to 1 upon 2 times coefficient of x square. So what is the formula for last term? You write half of coefficient of x and then write square of that. This is the formula for last term. Okay, it will be clear when I take a problem. So in order to explain the first two steps, let me have a question here. Suppose here I have 3x square. I have to integrate 3x square plus, say I have to integrate 1 upon 3x square plus 6x plus 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 5 dx. So you have the quadratic expression here as 3x square. What's the quadratic expression? It is 3x square plus 6x plus 5. I'm taking it out, but while writing the solution, it will remain there only. Here I'm taking it out because we are not solving this question. Instead, I'm just making you understand the two steps. So the first step was make the coefficient of x square equal to 1. So what you will do, you will take 3 out. Okay, you will take 3 out. So x square coefficient will become 1. I'm taking 3 common. So here I get x square plus 2x plus 5 by 3. Because when you take 3 common, 3x square, you are left with 1x square. 6x, you are left, since you have 3 common here, a common factor, 3 into 2, so you are left with 2x. And there is no common factor 3 here, so you get 3 in the denominator. So this is 5 by 3. Very good. So this is the first step. This is what I meant by saying make the coefficient of x square equal to 1. So when I said make the coefficient of x square equal to 1, this is what I meant. Okay. The next step, we said that after making the x square coefficient 1, we shall go for finding the proper last term. Now what is meaning of proper last term? See students, here the quadratic expression which you have, you can check, you have x square plus 2x plus 5 by 3. This is first term. This is first term. Here you have middle term. And this one is last term. This is last term. But you know students, this is not the proper last term. If this is first term, this is middle term, then for these two, first and middle term, this one is not the proper last term. What is meaning of a proper last term? A proper last term is the one because of which the 3 terms will get you a perfect square. What I mean is this. Suppose, now for time being, you forget this and everybody focus on this thing. Suppose I have x plus 1 the whole square. So x plus 1 the whole square, if I expand, what will I get? I will get x square plus 2 into x into 1, that is 2x, plus 1 square, that is 1. So x square plus 2x plus 1 gives me a perfect square, x plus 1 the whole square. It gives me the perfect square, x plus 1 the whole square. Now here what I notice I have x square, I notice I have 2x, but I do not have the proper last term. What is the proper last term? It should have been 1. The proper last term is 1. So here I should have got 1. But what I have 5 by 3. So what I should do is I should try to get 1 here. Okay, and for that the formula was given to you in second step. Okay, so I go for the last term. So here I find out the last term, students. In these 3 I shall find out the last term. For these, here I shall find out the last term. What is the formula for last term? The last term formula is 1 upon 2 times coefficient of x. Now check, what is coefficient of x? 2. So what is 1 upon 2 times of this? 1 upon 2 means half. So what is half of 2? Half of 2 is 1. And then you square. What do you get? 1. See, you got the last term. What do you got? You got the last term. You got the last term. Very simple. 1 upon 2 times coefficient of x. Coefficient of x is 2. 1 upon 2 of 1 upon 2 into 2 is 1 and square of that. So you got 1 square, which is last term. What I will do next? Once I get the last term, which is 1 here, that 1 I shall be writing here. So see, the next step I will write is, the next step I will do is 3, then x square plus 2x plus 1. I will write 1 because x square first term, 2x middle term, but the last term, proper last term is 1. So after 2x I am writing 1. Then since I have written plus 1, I need to write minus 1 because I am making a change. See, I wrote plus 1 from my side, so I must make a counter change. So minus 1 and plus 5 by 3. So I write 5 by 3 here. Now what happens, students? These 3 terms will get me the perfect square. These 3 terms will get me the perfect square. And for this, I shall simplify and write something which will come in the later steps. Okay, so I have explained you these 2 steps very clearly. So after first 2 steps, these all steps will be much clear when we take a problem. So as such, you shouldn't be worried. Step 3. Step 3 is after I have found the proper last term. After I have found the proper last term, see, I will write add and subtract. Add and subtract the last term in the quadratic expression to get a perfect square, involving variable. Now what is meaning of involving variable? It simply means that when you will get the perfect square, that perfect square will have x in it. So that perfect square will involve a variable. So we will add and subtract. As you saw, I explained you will add and subtract the last term in the first 2 terms, first term and middle term, to get the perfect square involving variable. Okay. Step 4 is write the denominator using variable square. See, variable square you have already obtained. You have to make a try to get variable square along with constant square. So write the denominator using variable square and constant square. So that the theories from set 1 can be used. Okay. So what will happen, students? Once you get the variable square and constant square, suppose I get a variable square here. Okay. I've got some variable square here, and then plus or minus, I get some constant square here. Then what I can do? what can I do? I can use the set 1 3 theories. I can use set 1 3 theories. What are those? Those are 1 upon x square plus a square dx, which is 1 upon a tan inverse of x by a. 1 upon x square minus a square dx, which is 1 upon 2a log of x minus a upon x plus a. Or I can use 1 upon a square minus x square dx, which is 1 upon 2a log of a plus x upon a minus x. So finally, what have we done? Try to understand. The first theories from set 1 can be, okay. So here, finally, what are we doing here? We are transforming. Try to understand, students. I was given a question in which the integral was such, and I found that at that stage, I did not have any result applicable here. I found there is no result applicable here. So what did I do? I used techniques, several methods in order to transform. So what am I doing? See, all these steps are being used and I'm transforming. I'm transforming it to what? I'm transforming it to a form. I'm transforming it to a form where I can apply the results. The basic steps of integration are never changed. Once I transform that 1 upon quadratic, I transform into this, and then I can use the result which I have already devised. Okay, so the type I have explained. Now it is time we solve few problems. I suggest you, before we go for solving problems, I suggest you should write everything which I have written for you. Let's solve a problem on the similar type that we just now discussed. So here I have a problem. It is exercise 3.2 B. I am using the book in which it is exercise 3.2 B and question number 13th, first 13th. These numbers hardly make any difference because you could be using whatever textbook you have from your specific board. What is important is the type of problem and the concept for solving those problems. You can have any textbook, any reference book, any notes. From there you can take the questions and solve. So let's begin. It is, I have to integrate 1 upon 5 minus 4x plus 3x square dx. So I write this as I. Let I equals to 1 upon 5 minus 4x plus 3x square dx. 1 upon 5 minus 4x, it is not plus, it is minus 3x square. So let me make a change here. 1 upon 5 minus 4x minus 3x square dx. So what type it is? It is 1 upon quadratic. But I notice that a is minus 3. So first I'll have to make this x square coefficient as positive 1. So what do? I take minus 3 common. So when I take minus 3 common, I get here x square. I get here x square. Then here I will get, see, minus is out. So this negative sign will become positive. So it will become 4x. And since there is no 3 common factor, I will get in the denominator 3 and plus 5. Plus 5 will become minus 5 by 3. Why the sign will become negative? The sign will become negative because I took that negative 3 common. Now 5 being a positive number, I will get a negative sign here and upon 3 because there is no common factor. So this is first step over. What is first step? Make the coefficient of x square equal to 1. Then what was the second step? The second step was find out the proper last term using the formula. What was the formula for last term, students? The formula was last term equals to half the coefficient of x, half. 1 by 2 when you multiply, you actually get half. So half of coefficient of x square. So here I notice coefficient of x is 4 upon 3. What is coefficient of x? It is 4 upon 3. So what is half of 4 upon 3? Half of 4 upon 3 is 2 upon 3. Half of 4 upon 3 is 2 upon 3. And then square of this is 4 upon 9. 4 upon 9. So what is the proper last term? The last term is 4 upon 9. Okay. Now finding out the last term as such, it is not a step to be written in your solution. Okay, remember that. You don't have to write actually finding the last term. You can do it anywhere. It's a kind of rough work. You can do it. Okay. Or many a times you can do this orally. Half of 4 by 3 is 2 by 3. Square of that is 4 by 9. 2 by 3 square is 4 by 9. So I got the last term as 4 by 9. What I will do, I will add 4 by 9 and subtract 4 by 9. So I equals to, first of all, this minus 1 upon 3 is out. Negative 3 in the denominator, which is a constant, I shall write it out. And here I have 1 dx, and the denominator is x square plus 4 upon 3x plus 4 by 9. I add the last term is 4 by 9. 4 by 9 minus 4 by 9 minus 5 by 3. I add the last term, so I subtract the last term. Then after adding the proper last term and subtracting, what I notice that these first 3 terms, they will get me the perfect square. So I got the perfect square. So I equals to minus 1 upon 3. And then here I have 1 dx. The first 3 terms will get me the perfect square, which is x plus 2 by 3 the whole square. X plus 2 by 3. See, x square gets me x. Then this plus sign, the middle term is positive. That will get me positive. Then 4 by 9 will get me 2 by 3 and then whole square. Now for these 2 terms, I take negative out. When I take negative out, I get 4 by 9. And here I get plus sign because I took negative out. 5 by 3 will become 15 upon 9. What I did, I multiplied 3 up and down so that I could add. I made the denominator same. So I multiplied 3, so 15 by 9. And then I have I equals to negative 1 by 3. And 1 upon, I have here x plus 2 by 3 the whole square minus this is 4, and 4 plus 15 is 19 over 9 and dx, 19 over 9 dx. Next step I have, therefore I equals to negative 1 by 3 and 1 upon negative 1 by 3 and then 1 upon x plus 2 by 3 the whole square, x plus 2 upon 3 the whole square minus, as I have to apply the results, which is variable square and constant square, this 19 over 9, I will be writing it as root of 19 upon 3 the whole square. How will I write? I will write root of 19 upon 3 the whole square dx. Now students, see what I have. I have got a result applicable here. See, this is what my aim was. Every single time, don't forget what is your aim. You are integrating any given function by applying result. Now here when I notice that as such no results are applicable, so what happened? I wrote this as this, then this, all. What is going on? This is nothing but transformation. You are trying to write the given integral into a form where you could apply the result. Now the moment you notice that result could be applied here, that's it. Your job is as such over. And what you will do now, you will apply the result. So here, which result shall I apply? It will be 1 upon variable square minus constant square. If you remember, it was 1 upon x square minus a square dx, which was 1 upon 2a log of x minus a upon x plus a plus c. This was the result. 1 upon variable square minus constant square. I will apply this. Okay, here. But there is one more thing, students, you can think of. Outside you have a negative sign. See here, outside, since we had taken negative 3 out as common, you remember negative 3 was taken as common. So because of this negative 3 outside, this negative sign is being taken outside the integral. If you want, you can take this negative sign in. Yes, you can do that. You can take this finally after having done, after having obtained the goal that you wanted to. You can now take this negative sign in. When you take negative sign in, it will become 1 upon 3, 1 upon 3, and the whole scene will change. Here, once you take this negative in, then what will happen in the denominator? I'm taking it inside in the denominator. So this negative constant square will become positive. It will become positive. So root 19 by 3 the whole square, and this positive variable square will become negative. It will become x plus 2 by 3 the whole square and dx. Okay. So you should try to understand, students, had I applied the result at this stage, had I applied the result at this stage, I would have written my answer as minus 1 by 3 and then apply this result. This minus 1 by 3 will remain as it is, and then I will apply this result. But I changed my plan. What is my plan now? My plan is not to have negative sign outside, to have a positive sign outside, and now I have something different. I have something different. What different do I have now? I have to apply the result, and that result is 1 upon constant square minus variable square. Okay. And what is it equal to if I apply it here? It is 1 upon 2a log of a plus x over a minus x plus c. So it's your choice, whichever you apply. If you want to apply it here, you can do it. You will have to apply this one. If you take negative sign inside and you apply here, you will have to apply this one. In either cases, the answer that you get finally is correct. Okay. It may look different, but the answer that you get finally is correct. So I prefer applying without a negative sign. Okay, outside negative sign, I don't prefer. I took it inside. So I will have to apply this result here. Okay. So I will get therefore I is 1 over 3, and 1 upon 1 upon 3 is outside, and then for this 1 upon 2a, 1 upon 2a, a is root of 19 by 3. Okay, a is root of 19 by 3, then log of a plus x upon a minus x. So root 19 by 3 a plus x plus 2 by 3 upon a minus x, that is root 19 by 3 minus x. So when you write the negative of this complete variable, it will be negative x minus 2 by 3 and plus c here. Now this 3 cancels this 3. So I get the final answer as follows. My final answer will be I equals to 1 over 2 root 19, 1 over 2 root 19 log of 3 is LCM. So I get here 3x plus 2 plus root 19, and 3 is LCM even in the denominator, minus 3x minus 2 plus root 19 plus c, and those 3 in the denominators, they cancel. Okay, the LCM for this is 3, so I will have 3 in the denominator for here, and I will have also 3 in the denominator for here. So this is the final answer. I hope you have followed it. You can watch the whole solution once again and also write it. Thank you. So We just now solved problem on the type 1 upon quadratic. You saw how did we go ahead for 1 upon quadratic. First we made the coefficient of x square as 1, and then we found out the proper last term, and then after getting the proper last term we added that, we subtracted that so that we could get the perfect square involving variable. We also managed to get a square involving constant, and once we got variable square, constant square, we could use one of the three theories that we have in set 1. After this, students, the next type that we are going to take is 1 upon root quadratic. Okay, so the next type is with a small change. And what is the change? The change is that you have square root in the denominator. The next type is you have 1 upon root quadratic. So the earlier was 1 upon quadratic. Now we have 1 upon root quadratic. So integral 1 upon root of quadratic. What we will do if I have, how to integrate if I have 1 upon root of ax square plus bx plus c. What is the difference between this type and earlier type? The earlier type was without the square root in the denominator. This time we have square root in the denominator. We have the quadratic expression ax square plus bx plus c inside the square root. Okay, so the same way, if I want to write here, I can say or 1 upon root quadratic. So the type is either you say 1 upon square root of ax square plus bx plus c, or you say 1 upon root quadratic, where a, b and c are real constants. So this is the next type. What is the method? The method is absolutely same, exactly same method, no change at all. First step, we will make the coefficient of x square equal to 1. Second step, the second step is find out the proper last term for the quadratic expression using the formula last term equals to half the coefficient of x the whole square. Then we will add and subtract the last term which we obtained in the quadratic expression to get a perfect square involving the variable. Then we will write the denominator using variable square. We will try to get one variable square and one constant square so that the theories from set 2 can be used. This is change here. What is change? Now we will have the theories from set 2. Why set 2, my dear students? It is because this time we have square root in the denominator. We have square root in the denominator. So what would happen? After you will have changed the, after you will have transformed 1 upon quadratic into a variable square and a constant square, you will get something like this. You will get 1 upon square root and some variable you will get here square and some constant you will get here square. Then once you get this, which theories are you going to apply? You will apply the theory from the set 2, the three theories from set 2, which was 1 upon square root of x square plus a square dx, and the answer for this was log of mod of x plus the square root as it is. Or you may have 1 upon square root x square minus a square dx. The answer for this was log of mod of x plus square root of x square minus a square. And finally you can have 1 upon a square minus x square dx. You will apply any of these, you will apply any of these three theories in order to integrate this. Okay, in order to integrate this. So this is the type you have. What I will suggest you is to write the type. Write the type. You may not write the method once again because method is exactly same. just make a note that in this we will use set two theories. We will use set two theories. So what I suggest you is, please make note of this type. It is 1 upon root quadratic. So now we will solve a problem on 1 upon root of quadratic. The type is 1 upon root quadratic. So we have question number 16 from 1, and that is I equals to 1 over square root of 8 minus 3x plus 2x square dx. So what is the method? Method is we will make coefficient of x square equal to 1. We will make coefficient of x square equal to 1. That is my first step. So I take here, I take 2 common, but remember, don't take that 2 outside the square root. It will remain inside the square root. So you have x square minus 3 by 2x plus 4 plus 4. Okay, you will take 2 out. So here you get x square, you get minus 3 by 2x and plus 4. Now, as you know, students, that root of AB is same as root A into root B. Okay, so what will happen next, students? This 2 will go out as square root of 2. So I can write this as 1 upon square root of 2, and then for this I write a complete separate square root, x square minus 3 by 2x plus 4 and dx. Now after this, my aim is to write the content of the square root as perfect square, and for that I will find out the proper last term. I shall find out the proper last term. I told you the method for finding the proper last term. As such, you don't have to show the calculation of last term. What you can do is you just calculate it somewhere. Okay, so the method is you get the half of coefficient of x. What is coefficient of x? It's minus 3 by 2. What is half of this? It's minus 3 by 4. Half of 1 upon 2 into coefficient of x. So it is minus 3 by 4. And then you write the square of that. The square is 9 over 16. So what you have to do, you will add and subtract 9 over 16 here. You will add and subtract 9 over 16 here. Why? So that you can get the perfect square. You can get the perfect square here. Okay. So let's do it. So the next step I write is, therefore I equals to, okay, this 1 upon root 2 being a constant, it can be taken outside the integral sign. And here I have 1 dx, and then I have square root of x square minus 3 by 2x plus 9 over 16. I add 9 over 16. I shall subtract 9 over 16 and plus 4. Okay. Then I have here 1 over root 2 and 1 upon the first 3 terms being the perfect 3 terms. It will get me a perfect square. I mean, these 3 terms are now going to get me a perfect square. And what is that perfect square? It is x, then the negative sign from the middle term, x minus 3 upon 4, the whole square. Okay. And what about these 2 terms? Remember, students, I warn you for these 2 terms. It is found that students commit mistake while calculation in these 2 terms, and if you do so, it is such a silly mistake. So you should be very careful while doing this calculation. I shall suggest you what you should do. When you notice that one of the fraction is negative or positive and the other is the opposite sign, you always write plus sign outside. Always write plus sign outside, then make a bracket. Now, the idea of writing plus sign is, now if you take LCM, the numerator, you may not change the sign because outside you have written plus, here you have written plus. So inside the bracket in numerator, you may not change the sign. So this will remain 19 and this will be 64. Okay, so negative was negative and positive was positive. So next step you get is 1 over root 2 and 1 upon square root of 1 upon square root of x minus 3 by 4 the whole square plus 64 minus 9. 64 minus 10 would be 54. So this is 55. 55 upon 16 upon 16. And here you have dx. dx shouldn't be forgotten. So I have I equals to 1 over root 2 integral 1 dx. And here I have, see what I have. I have x minus 3 by 4 the whole square, x minus 3 upon 4 the whole square, plus this is 55 upon 16. I will write that root 55 upon 4 the whole square, root 55 upon 4 the whole square. So now I have 1 over square root of, I'm sorry students, I had not been writing square root. Oh my God. No. I'm writing. I thought I had not been writing. Okay. So here I just did not write in this. Elsewhere I have written. So I write the square root here also. Okay. So what I have got 1 upon square root of x minus 3 by 4 the whole square plus root 55 upon 4 the whole square. Even this has to be written in the form of constant square. Now what I notice that I have got now this in the form 1 over variable square. It is variable square plus constant square. 1 over variable square plus constant square. So I will apply this 1 upon square root of x square plus a square dx. And what is it equal to? It is equal to log of mod of x plus square root x square plus a square plus c. Log of mod of x plus square root x square plus a square plus c. This is what I will write. So here what will this become? Applying that result, it is 1 upon root 2 and log of mod of variable. What is variable? X minus 3 by 4 plus square root as it is. It is square root to be written as it is plus c, which is x minus 3 by 4 plus root 55 upon 4 the whole square. Okay. So I have written this. Now one thing I would like to mention here, students, that having written the answer, you notice that inside the square root, the answer that you are writing, it is looking too big. You know, it is not looking compact answer. Now this could be made a compact answer. See how? How can it be made a compact answer? See, inside, forget about this variable, look at the square root. Inside the square root, I have this. Now the question is that where is this coming from? It is coming from here. You all agree? Yes, it is exactly which I copied. Fine. Now in this square, in this content of the square root I have. Now if I ask you that where is this coming from, where is this coming from, this content, so it is coming from its previous step. What was it? It was this. The only difference is here you have 55 upon 16 and here you wrote root 55 upon 4 the whole square. Okay, fine. So what I understand is this is nothing but this, which is nothing but this. Okay, fine. Now the next question is that this one which I have written, where is it coming from? Where is this coming from? This one. So it is nothing but this. Okay, which is same as this, hardly any change. You understand? Which is same as this, Okay, so what I would do, students, in order to make my answer look compact, x square minus 3 by 2, x plus 4. So here what I shall write, I will not write this. Instead, I will write here, okay, I forgot to write this as a square. I have to write the square root as it is. So this was x minus 3 by 4 the whole square, which I forgot. I wrote it now. So excuse me for forgetting that. So where was I? Yes, I was asking you that in order to write my answer looking compact, what I can do is I can write this x square minus 3 by 2x plus 4 here. Where? Here, because this thing is same as this thing. Okay, so the next answer is I equals to 1 over root 2 log of mod x minus 3 by 4 plus square root of, I would write x square minus 3 by 2x plus 4 plus c. This is what I will write. Okay, and this is the final answer. I hope you followed. You can once again watch the whole thing and also practice it. Thank you.